Bismillahirrahmanirrahim. Dear students, how are you? Hoping that you are all fine and good, enjoying your life at home. Be safe and pray for all of us. In the previous lesson, we discussed on Wednesday, we discussed about the distance time graph and speed time graph, and those both graphs and their work was completed. In today's lesson, we shall go one step further, and today's lesson is about the equations of motion. Now, equations of motion. There are three equations of motion for bodies moving with uniform acceleration. In these equations, five parameters or five variables of motion are involved. These are initial velocity Vi, final velocity Vf, acceleration A, time T, and the distance covered S by the moving body. To simplify the derivation of equations, we consider two aspects. Number one, the motion of bodies along a straight line. Number two, magnitudes of displacement, velocity, and acceleration are used. As you know, these are three vectors, but in deriving equations, we shall use only their magnitudes. So, consider a body which is moving with initial velocity Vi in a straight line with uniform acceleration A. Its velocity becomes Vf after time t. The motion of a body is described by the speed time graph. Now we consider that the slope of the line gives us acceleration. That is, whenever we shall draw the slope, we are going to calculate its acceleration from the graph. Number two, the total distance covered by the body is found by calculating the area under the graph. Now, first equation of motion. The graph is same. You can see the graph. Graph is same as in your book. And first equation of motion, we are going to derive first equation of motion. The speed time graph for the motion of a body is shown in the figure. You can see all the graph that on horizontal time is taken and on vertical velocity or speed is plotted. From O to A, the speed is constant. From A to B, the speed is changing uniformly, increasing uniformly. And at B, speed becomes final or Vf. Okay, the speed time graph for the motion of a body is shown in the figure. The slope of the line AB gives the acceleration A of the body. Let's calculate slope of the graph. Slope of the line AB is equal to A is equal to BC, mean vertical component of this triangle, divided by AC, mean base. You may say rise over run. BC is rise, AC is run. That is equal to, in terms of total graph, BD. BD is the total distance from 0 to VF or from D to B. So BD is the total distance minus CD is the distance from C to D. So BC is equal to BD minus CD divided by OD, that is base or horizontal. Now as we see that BD is VF, CD is VI, and OD is T. Using these values in above equation, we get A is equal to VF minus VI divided by T. Multiplying T on both sides, we get Vf minus Vi is equal to At, and shifting Vi from left towards right side of the equation, we get Vf is equal to Vi plus At. This is the final form of first equation of motion. Now, second equation of motion. In this equation of motion, you can see graph is same in all respects. So for second equation, what we process will do, let's listen and see. Consider the speed time graph as shown in the figure. The total distance covered by the body is equal to the total area OABD under the graph. This is total area under the graph OABT. Total distance S is equal to, this area is in two parts. Area of rectangle OACD. This is a rectangular part of the graph. Plus area of triangle ABC or ACP. Now area of rectangle is OA multiplied by OD, means length multiplied by breadth, plus half multiplied by AC multiplied by BC. It means 1 by 2 times base into height. This is area of triangle. Using values as shown in the graph, OA is equal to VI, OD is equal to T. So OA multiplied by OT is equal to VI multiplied by T, plus half or 1 by 2 times T. T is equal to AC or OD, one and the same. So T multiplied by AT. AT is taken from BC. BC length is equal to AT. So above equation is equal to VIT plus half AT square. Hence, S is equal to VIT plus half AT square. This is final form of second equation of motion. Now, last or third equation of motion. In this motion, a graph, in this equation, you can see graph remains same. So consider the speed time graph as shown in the figure. Total distance S covered by the body is equal to the area of trapezium AOABD, area of trapezium, and this is trapezium. Total area is equal to half times sum of length of the please see again, total area is equal to half times sum of length of parallel sides uh, multiplied by length of the base. Now, which sides are parallel? OA is parallel to BD. These are two vertical sides, but in with each other, these are parallel. So we say sum of parallel sides. OA plus BD times OD. And we know OA is equal to VI, BD is equal to VF, times OD is equal to T, equal to half times rearranging. Vf is taken as first part. It is just change of position, nothing else. Vf plus Vi times this part of the equation is taken from first equation. We may derive from first equation that T is replaced by Vf minus Vi divided by A. So T from first equation is equal to Vf minus Vi divided by A. So replacing T by this factor, we get uh, in next part, we multiplied on left side by 2 and a. So in the second last step, we see 2as is equal to Vf plus Vi times Vf minus Vi. Using here mathematical formula a plus b times a minus b is equal to square of first factor minus square of second factor, and we have Vf square minus Vi square. This equation can be written as in the proper way, that is Vf square on left side is equal to Vi square plus 2as. So in the final form, first equation in the standard form is Vf square is equal to Vi square plus 2as. Thank you very much. Yes, sir. Sir.